Okay, let's have a look at unsaturated hydrocarbons. And in this case, we're going to look at alkenes and alkynes. So an alkene must contain at least one carbon-to-carbon double bond. And an alkyne must contain at least one carbon-to-carbon triple bond. Our general formula for our alkene, where it contains only one unsaturated bond, or one carbon-to-carbon double bond, will be CnH2n. So we have the simplest alkene, which we call ethene. Eth, the prefix eth means 2. So we draw out this structure as C, double bond C, with 4 hydrogens. So if our ethene has 2 carbons, we have 2 times 2, which is 4 hydrogens. Our alkyne, with one carbon-carbon triple bond, will have the general formula CnH2n-2. So our simplest alkyne will be ethyne, and we'll have a carbon-carbon triple bond. We substitute 2 carbons in there to give us 2n-2, which is 2 times 2 minus 2, to give us 2 hydrogens, and we put our 2 hydrogens on. So when we're naming alkenes, we use the suffix -ene. So I've used -ene for ethene. Our alkynes, we use the suffix -ine, Y-N-E, so we have ethyne. So let's look at the structures of our first 5 alkenes and alkynes. Carbon number 1, we can't have any double bonds. So we don't have a methine or a methene. Instead, our simplest alkene and alkyne will be ethene and ethyne respectively. And as we saw on the other slide, we have carbon-to-carbon double bonds, 4 hydrogens, and that's our ethene molecule. We can represent this in a shorthand way with our double bond. Our next simplest alkene is propene, and we're just using one double bond. So we have carbon-to-carbon double bond, and then across to a methyl group. So we get a carbon chain of 1, 2, 3 to give us propene for the alkene. And we can represent this in a shorthand manner as a double bond, and then a single line for a single bond. Our next simplest model is 4 carbons. Now you'll note that I have here 1 butene, so we're denoting that the double bond for butene will be at carbon number 1. So we have number 1, 2, 3, 4, and as we move along, our double bond is between carbons number 1 and 2. Now I haven't put the hydrogens in any of these molecules for simplicity's sake. So we can draw this in a shorthand manner. Once again, we have our double bond. We come down to here again, same as this model, and we have an extra line denoting the extra CH2 group in the middle. If we move down to 5 carbons, we'll make this simple by having 1 pent for 5 carbons, ene for the alkene, so we have our double bond plus our 4 other carbons. We can represent that in a shorthand manner with the double bond to a CH2, CH2, CH3 group, and we get 1 pentene. We can do the same thing with our hexene, this time 6 carbons. At carbon number 1 we have our double bond, and shorthand, double bond, CH2, 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 CH3. Now obviously we can have double bonds or more than 1 double bond in these molecules, and we would represent it in the same way. So we can have this sort of molecule, which would be 1, 3, dibutene. So we can also do the same thing with our alkynes. So our simplest alkyne will be a carbon-carbon triple bond with 2 hydrogens this time, and we can represent that in a shorthand manner as 3 lines. That denotes our triple bond. Our next most simple alkyne will be propyne, carbon-carbon triple bond to a CH3 group. So triple bond across to our CH3 group there. We can move down to 4 carbons. This time we're going to have our triple bond at carbon number 1. So carbon to carbon triple bond, a CH2, a CH3 group. So shorthand wise, we've got our triple bond, CH2, CH3. And we move down to one pentyne. So 1 denotes the triple bonded carbon number 1. And we move across to our CH2, CH2, CH3. So we denote that in a shorthand way as the triple bond, CH2, CH2, CH3. And then finally, we have one hexyne, so 6 carbons. At carbon number 1, we have our triple bond, CH2, 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 CH3. So we have our triple bond, CH2, 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 CH3.